welcoming you to Global AppSec. I'm really excited to be here. And this talk is actually 26 years in the making. I'll talk about the off by one error in just a minute. But 26 years ago, I was working for a bank, and it was my first AppSec role. And so I recently was rebuilding my website. I found this file, which I had put on the web, and I was like, wow, this thing is 25 years old. It's a few months older than Aleph 1's Smashing the Stack, which had its anniversary just a couple of days ago. And so I started thinking about how has the world changed in this time? And that led me towards where are we now and how will the world change? And so with that, let's get going. Martin gave me a very kind introduction. I don't need to do that. And my agenda today is pretty simple. It is the past, the present, and the future of AppSec with some remembrances along the way. And so let me start out in the past. So in 1995, I was contracting at Fidelity Investments and reviewing code that went into their firewall systems. And there was a lot of competition at the time to provide financial services via this new World Wide Web thing. And that competition led to tension between the business and security. Weird. I mean, we've solved that one, right? But we haven't really solved that one. And this is an example of the way in which the world stays the same, which I'll talk about. But I wrote a set of guidelines to help manage that conflict better. And I got the okay to share these in August of 1996. And I want to thank the folks at Fidelity. I'm not speaking for them, obviously. I want to thank Steve McClellan. And if I had better notes, I would thank the whole darn team because it was a great team to have worked with. But let me explain the situation in a little more detail. So, situation looked roughly like this. There were web browsers like Netscape Navigator, and people would use that to connect to a proxy, and the proxy would terminate TCP, would send a request based on its code to some internal system. And that was custom code that was being written by teams around the company. And we were aware even then that that code was in danger in various ways. And so what we did was we created these code review guidelines. And you can see here, that this document has two purposes. It was a guideline and checklist for the security team, and it was an attempt to give the development teams information about what we were going to look for. In a sense, this is what we now talk about when we talk about paved roads. And it was a much more primitive approach than today's paved roads, but it is in a sense a precursor. And at the end of this talk, I'm going to give you a link to my blog. It will have the slides, the final version of the slides, a few minutes after the talk concludes. And it will have all of the links which are in this talk, which I think are interesting for you to follow. So you're welcome, of course, to take screenshots, but all of it will be available in a few minutes. So what's in the guidelines? What's in the guidelines is some discussion of architecture, including what data flows do you have. There is some discussion of logging. There's specifics like Chroot. Chroot is an early sandboxing technology, and we knew there were issues with it. For example, if you had a had a link out of the true area, the attacker could follow that link and break the sandbox. So there was input validation. We knew about dangerous functions like gets and system and even stir copy. And these guidelines were focused on C, C++, and Perl, because that's what was current at the time. Looking back, there were a lot of things we didn't have. We didn't have any tooling, literally no tooling. We didn't have static analysis. We didn't have fuzzers. We didn't have books that were focused on software security. Gary McGraw's Building Secure Software, Mike Howard and Dave LeBlanc's Writing Secure Code, Lincoln Stein's Web Security. These were all in the future. We didn't have consultants who were focused on AppSec. We didn't have penetration testers who called themselves that. We didn't have structured threat modeling. I was not aware at the time of Ed Amoroso's work on attack trees. The book had published a year or two earlier, and I wasn't aware of it. But we did have business conflict, and we had a need for support. We had a need to help people move quickly. Some other perspective, I mentioned Smashing the Stack, 25 years old now. Happy birthday to that paper. We had some mailing lists and Usenet as our forms of community on BugTrack, on the original Firewalls mailing list, on Cypherpunks. There was discussion of secure coding, but there was no place where we in AppSec could get together and talk in depth about what it was we were trying to achieve. We did have some great books. Cheswick and Belivin's Firewalls and Internet Security talks about the difficulty of patching all of that code, of finding all of those vulns, and therefore the need to use firewalls to protect what's inside until we can make those updates. Spafford and Garfinkel's Practical Unix and Internet Security does talk about writing secure code. There's a few pages in the network proxies section on writing your own, and in the chapter on safe network and set UID programming, there's a good 3 pages. And that was what we had to go with. A lot of the framing of how we were thinking about security was papers like this one by Dan Farmer and Witsi Venema, improving the security of your site by breaking into it. This was a very attacker-centered viewpoint. We're going to run some network scans to find vulnerabilities and exposures. And in doing so, we're going to find the things that you need to reconfigure, harden, turn off so you can protect your systems. Now, moving forward, going across 25 years of AppSec incredibly quickly, Martin mentioned that OWASP just had its 20th anniversary. Happy birthday. Microsoft's trustworthy computing memo and secure development lifecycle happened. And I joined Microsoft a few years after this. When it came out, I was really skeptical. But what we saw was that a big company that ships a lot of software could take on the idea that everyone was going to engage with security and be responsible for it. And in the early days, they even stood down and delayed ship on products. And in 2001, 2002, not only was that a shocking choice, it was doubly shocking that it was Microsoft that would do it, because we talk about move fast and break things today, or ship it and fix it in V2. Microsoft was big on that at the time. There's been a profusion of commercial tooling, static analysis, fuzzing, runtime app security, orchestration, threat modeling tooling. There's just this wonderful availability of both open source and commercial tooling to help you get your job done. seen a rise in bug bounties, jobs in bug hunting and penetration testing. We've seen the rise and fall of entire bug classes like SQL injection or PHP. And SQL injection, 1999 or so, and over the last few years, I've seen people bringing up the question of, does SQL injection really happen in new code anymore? Is it really a problem? And of course, PHP is not a bug class. It's a lovely programming language, which makes it easy to write code, and easy to write code which surprises the developer and delights the bug hunter. We've also seen a massive shift in breach reporting, the idea that you can cover up an issue, and I'm going to return to this later on, but the idea that you have to talk about certain classes of security problems, I believe to be new and really important for our field. I also want to mention a little bit more broadly development. I remember going to data centers and talking about the physical layout of hosts in the data center back in 1996. And since then, we've had the Agile Manifesto, we've had the rise of DevOps and SRE, we've had the rise of cloud. Software as a service wasn't a thing in 1996. Virtualization wasn't a thing in 1996. We've had mobile platforms, iPhone and Android, and I'll talk about the security importance of those things. But in 1996, I was carrying in a pager, displayed 2 whole lines of text at a time, and I could go backwards and forwards between those lines. It was pretty cool. And so there's been really tremendous change, and it's important to understand that as we get to the present, because there have been more really important changes. So one change, which I think we have not even seen the full value of yet, is security properties and features are moving through much more of the stack that we use to deliver software today. It's not something that we just bolt on or you harden the operating system. Excuse me. We see languages that have security goals like Rust. We have frameworks, React, Angular, that have security properties. We have security chips. Apple's T2, Windows 11 needs a TPM. I was seeing over at Black Hat right now, there's a talk on the Google security chip and its properties. And we even have, and I think of all the things, this is one of the most surprising to me, is that formal methods have actually been taken from academic use to real systems. Amazon has talked about their use of the TLA plus temporal logic analyzer to prove certain properties about the systems they're building in the cloud. We have LangSec. LangSec helps us frame the security of new languages, especially, but not limited to, domain-specific languages, so we can think about what is it that we're building and what are its security properties in ways that I think are enabling. And iOS, Android, these mobile-first apps that we're creating are built with compartments that are much stronger, much more containing than anything we could have thought about back then. There's also been a lot of progress at the governmental level. In 1996, we had the Orange Book or the Rainbow Series, and we had crypto export restrictions that made it hard to incorporate cryptography into our products. 2021, the President of the United States issued a long executive order on cybersecurity. We have ever-growing breach reporting requirements. We have things like the security bill of materials. You must, and there's some interesting looking SBOM talks here at Global AppSec. The idea that you actually have to know and talk about everything in your software is new. And this presents some challenges if you're doing something like NPM. It's not that you can't, but you actually have to think about bringing in new modules because they'll become customer visible. The Food and Drug Administration is recommending threat modeling to medical device manufacturers. NIST has released a set of secure software development framework. They're at version 1.3 or so. They released software verification guidelines as a result of the executive order, and they put threat modeling front and center. And hey, in 2021, insecure design has made the top 10. And I'm excited by that. And also, to be completely blunt, a little disappointed that it's taken us so long. But I'm only a little disappointed because when I think about it, there are good reasons for that, which are worth thinking about and understanding. And so I think the first reason it's been hard to get insecure design is because actually fixing issues like injection has been hard. So there's a lot of it. It's visible, right? Nobody looks at a SQL injection issue and says, oh, that's a feature, not a bug. There's never any debate over whether or not a bug like SQL injection or a remote code execution is a problem. And so it's easier to fix. And I think one of the challenges that we as a community will face over the next several years is design choices, design trade-offs are different than many of the things that have been in the top 10. And I'll talk about how that's going to play out, or how it might play out in some of the challenges we face. Another issue is that design is a dirty word. People don't like talking about design. They don't like talking about architecture. Oh, we're agile. We don't do architecture anymore. And that's a response to some very heavyweight and perhaps not particularly useful practices in the past. But you do architecture. Everything has an architecture. It's just a question of whether or not you understand it. And we used to talk about threat modeling as think like an attacker, and that's really hard. So what are we doing about this? Stride by Lauren Konfelder and Prerit Garg is 22 this year. And by the way, Lauren has a new book, Designing Secure Software, which I really like, and there'll be a link to that in the links. We've largely settled on the 4-question framework of what are we working on, what can go wrong, what are we going to do about it, and did we do a good job, as a way to modularize threat modeling and enable experimentation. We can swap kill chains for Stride as ways to answer what can go wrong. We can swap data flow diagrams for state machines as we think about what are we working on. And so it enables experimentation. It makes it easier to teach and learn threat modeling. We have games like Elevation of Privilege and OWASP Cornucopia. We have books that make threat modeling accessible. We have a manifesto for threat modeling talking about patterns and anti-patterns. And all of these things enable us to bring insecure design into the top 10, to talk about it in our organizations in ways that are going to enable that conversation to happen. And I think it's going to be key to the future. And so talking about the future, let me start out by quoting a wise person who said, predictions are hard, especially about the future. And when I think about this talk, looking back 25 years and wanting to look forward 25 years, Thinking about all of the changes in development over the last 25 years, I can confidently say that I can't look out that far with any degree of reasonable confidence, except about one thing. And so I believe that the state and trends are going to continue. And in 25 years, our kernels will still be written in C. The reason I say that is because all of the kernels we use today, Mach, Linux, NT is a little younger, but if we want to replace the operating system kernels that we'll be using in 2046, time is running out. And so I believe we'll continue to see kernels in C 25 years from now. I also believe that the trend towards better security properties is going to continue. And that means that attacks at the seams are going to grow. I'll give you an example of this. So there was a great bug in how Apple managed p-lists. And it turns out they had two different parsers that managed comment closure differently. Somebody discovered this. And so one parser checked the validity of the p-list, the other one executed it, and they did different things with the comments. Oops. That's a seam between the two things. And those sorts of issues are going to grow. The other thing we're going to see is better and better isolation. And we talk about this in terms of blast radius. We talk about this in terms of virtualization. We talk about this in terms of more VPCs. We're going to see that continue. And so horizontal privilege expansion is going to become a thing that goes alongside privilege escalation. Being able to get from compartment to compartment, even in a lesser privileged sense, will be important. I believe ransomware is going to get really evil. And you might think ransomware is evil today, and it is. Just a few ideas. We'll see before I say my few ideas, today's ransomware businesses, and they are businesses, much as we dislike them, will go in, they will dig out their victim's insurance policy. And so when you argue that you can't afford the ransom, they'll show you your own insurance policy and say, yes, you can. And the price will go up. Ransomware attackers are investing in understanding their victims. Those investments will continue. And so, for example, they will change the manufacturing tolerances on your CNC machines. They will change the tolerances on your quality assurance processes. They will change email addresses in your CRM database. They will move data outside of your PCI boundaries so you don't pass PCI anymore. If you think about the ways in which they can be evil, there's unfortunately a lot of room for growth. And I believe we'll see much of that happening. AppSec is going to change. We'll see a change from attacks on systems to attacks through systems. And so when I look at the top 10, these are attacks on systems. They're attacks on the integrity, confidentiality, availability of the systems we're using. We're going to see, and we're already seeing, abuse, conflict, harm that runs through these systems, using the systems as designed and intended in ways that surprise their creators and hurt people, but the system still works. And we see companies responding to this with trust and safety style teams that augment the security work. They're parallel to what we do in AppSec. And I think we're going to see the two disciplines grow more together. We'll see a shift towards demonstrating trustworthiness instead, and less trying to bolt it on. We're going to see the growth of artificial intelligence. We're going to get more data-driven. Lastly, the frame in which we talk about these problems is going to matter increasingly. So let me go to AI. Let me start with AI. And the first thing I want to say is AI is a problem solver. So in 25 years, application security will be more mature. We'll have a lot more tools and a lot more people who know how to use them. And let me talk about AI as a problem solver, because this slide was actually written for me by OpenAI's GPT-3. It was solving the problem that I needed some AI-driven content. And it started out pretty well. And this was actually attempt number 4 for it. But other than the duplicated sentences, this sounds almost like something I would say. And so AI is really starting to do impressive work in very narrow ways. And I think some of the ways, and this is not written by GPT-3, by the way, this is actually my text again. Some of the ways it's going to improve are code review. We're going to see smarter and smarter systems. And we're seeing the beginning of this with automated copying and pasting from Stack Exchange. We're going to see that code get substantially smarter and be way less likely to write vulnerable code. Bug detection and remediation analysis will get better. We'll see composition analysis, those seams I talked about. AI will start to think about some subset of the way in which those seams happen. But AI is also going to be a problem area. We have to worry about the security of AI and machine learning systems. The Berryville Institute of Machine Learning and Microsoft all have interesting work in this area. I'll have some links for those in the follow-up. But AI and machine learning problems are not just security. There's questions of why did it do that? Explainability. There's questions of transparency. Do you tell your customers that you use AI? Do you tell them where you get your training data? Does that create a security issue for you? There's privacy issues with AI where it's hard to train a model without that model containing information about its training data set. There's environmental costs. I've read papers talking about the carbon emissions needed to create a new AI model. And there are issues of bias and fairness, which are tremendously important. And I want to share a little bit about a paper that I read recently, The Impossibility of Fairness. And what they point out is that definitions of fairness spring from worldviews. For example, we have a definition which is individual fairness. Individuals who are similar should be treated similarly. And we have a definition which is that demographic groups should be treated approximately the same across demographic groups. And they demonstrate in a mathematical way that you can have one or the other. And so in a sense, according to this work, all AI systems contain biases. And so it's trivial to say this AI system is biased, it's unfair to X, and we'll have to come to grips with that. And we as computer scientists are not particularly good at that. So we're going to need to develop skills at engaging with other disciplines, engaging with people whose worldviews, whose backgrounds are different than ours, and figure out how to deal with this problem in better ways than we do today. I also believe that AI is going to be a problem creator for us. So there's a great quip. Ransomware is just a pen test whose terms you negotiate after the report's been delivered, or it's a bug bounty whose terms you negotiate after the report's delivered. And so if AI is going to hunt bugs, different people will have different bug hunting systems, and some of them will be used at odds with our hopes and intents. DARPA did their Cyber Grand Challenge in 2016. It's 5 years old. And in that Grand Challenge, they had AI systems automatically finding bugs, automatically writing patches for them in a capture the flag sort of scenario. And they were doing it with a different machine language than we tend to see in the real world, but that's 5-year-old technology now. We're also going to see AI exploiting human beings. This is the attacks through the systems. We're going to see things like deep fakes and voice clones and text fakes being used in phishing. We're already starting to see that. And those are going to scale in ways that we are ill-equipped to manage. And as examples of this include things like stalkerware, the abuse of intimate imagery, some of which is faked, but has a psychological effect on the person whose image is faked. We see IoT being abused by abusive domestic partners who are forced to leave but still have access to the thermostat, for example. We've got trolling and swatting and the internet hate canon, and I'll talk about Jamal Khashoggi in just a minute. All of these are going to be negatively enhanced by AI. We've got election manipulation, it's cheap, and AI is going to play a huge part in both the attacks and the defenses. So before the Saudi government murdered him, Jamal Khashoggi was the victim of an internet harassment campaign. That harassment campaign is going to get worse. And the protective tools, those safety and trust tools, the report a problem tools, are going to be driven by AI. They're going to be attacked by false reports by bots and humans. We've seen an example of police officers playing copyrighted music when misbehaving and telling the people around them that they were doing it so that the people who were recording them couldn't post the video to YouTube because YouTube has automated takedown bots. How do we put that in the top 10? Going back to Khashoggi, who was the victim of this organized campaign that I believe was human-driven, Khashoggi was a thorn in the side. He was a reporter who upset the Saudi government enough that they murdered him. These campaigns will scale out to way more people way faster. And I don't believe we're ready for this. And so I want to mention people like Diana Fried and Karen Levy, Julia Slepska, Leonie Tanziker, who have been doing phenomenal work on threat modeling around abuse. They really have informed my thinking. There's some papers here. Those links will be in the blog post. And I've been doing some thinking about how we use the threat modeling framework of what are we working on, what can go wrong, what are we going to do about it, did we do a good job, in helping us think about conflict, because I believe it's going to be a tremendously important area. And I'm not alone in this. In his 2017 Black Hat keynote, Alex Stamos showed this chart. And he challenged the Black Hat audience. And he said, you know, Black Hat is all about 0 day. You're up here at the very tip of the pyramid. But the things that really hurt people are these password reuse attacks. They're these abuse attacks. And he asked, what are we going to do about that? And so I just want to echo his question and ask, is OWASP here? Is this the right place for us to be for the next 5, 10, 20 years? And if not, how do we expand? And I'm not saying we're not doing this, by the way. I want to respect the people who are thinking about this rather than trying to claim sole credit. But I believe it's important for all of us to be thinking about how do we expand what our community cares about and ensure that we're balancing our efforts in the most effective ways. Another interesting paper I read recently about demonstrating trustworthiness is informing my thinking as I think about where we're going. And they put forth a taxonomy where we go from testing or monitoring to formal verification or synthesizing code from specifications so that we can have higher assurance that it's trustworthy. And a lot of what we do is oriented around testing. My friend Eric Douglas has described threat modeling as clever test case planning or clever test planning. Not sure I agree fully with him, but threat modeling is often closer to testing and driving monitoring than it is to formal verification. And I think we're going to need to develop these techniques over the next 25 years. And when I think about synthesis, I also think about composition. And if I think about synthesis being from specification, we also have composition from the components. And as more secure components emerge, well, composition is, if you will, a shell-shockingly hard problem. And if you remember shell shock, it was everything eventually relies on bash and passes its input to bash. Oops. So specification is a really, really hard problem. Requirements are a hard problem. And I think AI will help, but I don't believe it will help as much as we may hope without better specs, better compositional techniques. So I think that's an area that requires attention from us all. And when I think about these problems, one of the questions that I ask myself is, how are we measuring these? How are we prioritizing what we work on? How do we figure out what's going on? And how do we assess progress? Excuse me. And there's a project whose report is close to dropping. And I've been working with Rob Kanacki, who's a non-resident fellow at the Belfer Center at Harvard's Kennedy School. And we are close to finalizing the report from this workshop on learning from cyber incidents. What we did was we took a set of models from aviation, a cyber NTSB, or a cyber near miss capability, brought together 70 people, and we've got a report that I'm really excited about because I believe that more and better learning from incidents is crucial to what we're going to do over the next 25 years. And there's tension over this. Nobody likes to admit to mistakes. But we have a trend towards faster timelines. So for example, this is a news report from last week. Senators moved to include a 72-hour reporting timeline for cyber incidents in this must-pass bill. And not in the headline, but in the body of the article, 24 hours if you make a ransomware payment. And we've treated this as a very one-dimensional problem of report faster and faster is coming to us from policymakers. I believe that we have a trade-off that's available to us. If we think about reporting not only in terms of timeline, but in terms of content, maybe we can get more by hearing about root causes. And that's a less quick reporting timeline, but we'll learn more and it will inform how we prioritize what we're doing in the field. And so I think that this is an important thing that is going to move in ways that we're going to look back in 10 years and 15 years even and say, wow, how did we work without that data? So what do we do? I think someone else said, the best way to predict the future is to invent it. And opportunities abound. We have synthesis and composition. There are challenges in AI. We have threat modeling and AppSec for conflict. We have, and I didn't really talk about this, but a number of folks have done really good work and pointed out that the threat modeling work, which I do, which we talk about, tends to be focused on creators of technology rather than the end users of technology. How should we help normal people whose choices are more centered around buying and configuring the technology in ways allowed by its creators? How should we help them think about their security? And so I think there are plenty of opportunities, and I want to close out by talking about the frame just a little bit. There's a lot of ways in which we speak of cybersecurity today. And I'm aware that I'm using the term cybersecurity, which still causes some people to eye roll because they're in information security or something else. But there's cyber war and cyber espionage. These are exciting frames for us to think about and hear about. There's criminals and hacktivists who cause a lot. The criminals cause a lot of damage. The hacktivists cause a lot of embarrassment. There's a frame that's very popular now of threat hunting and bug hunting. There's a frame of compliance. There's a lot of energy being spent in compliance management these days, energy being put into things like CMMC, vNext. And then there's AppSec, which sometimes seems like the poor cousin, if you will. And, at the beginning, I wished you all a happy Armistice Day, a happy Remembrance Day, a happy Veterans Day, because today is November 11th. It is the end. It's the date on which World War I ended. And World War I was, for most of the war, dominated by defense. The technological defenses were so powerful that attackers died by the thousands trying to overcome them with little success. And I think that that's a powerful thing to think about, because today our world is dominated by offense. And I look forward to a time when, despite the fact that this conflict is real, it's not going to go away, people are not going to become less motivated to attack us. We can build castles. We can build defensible systems that will last against determined attackers. And right now, the pendulum is on the side of the attackers, but that doesn't mean it always will be. I believe that the goal of AppSec should be to build these effective defenses. And so that is my hope. That is my request to you, is to build these defenses. Because going forward, I want to quote one last person and say, we're not at the beginning of the end. We're at the end of the beginning. This field is still new. There's still tremendous opportunities, and I am looking forward to the next 25 years. So with that, I want to say thank you very much for listening. I hope you've enjoyed this talk. I am happy to take questions. The slides will be at shostack.org/blog a few minutes after we close today. And yeah, thank you very much for your time and attention.